In today's lab, you will study Fourier analysis. Fourier's theorem states that any periodic oscillation can be represented as a sum of sine waves with different frequencies, phases, and amplitudes. Only harmonics, or multiples, of the fundamental frequency, equal to 1 over the period of the oscillation, are required. Additionally, there is only one combination of sine waves that will produce the given oscillation. Let's look at some examples. If we combine a 10 Hz oscillation with a 20 Hz oscillation of the same amplitude, we will get a superposition of these two waves. By shifting the phase of the 20 Hz oscillation by 1/4 wavelength, or 90 degrees, we will get a different superposition. We can represent the component waves of any oscillation as a Fourier spectrum. This is a plot of the frequency of the component harmonics, plotted on the x-axis, against the amplitude of each harmonic, plotted on the y-axis. We can think of Fourier spectra as unique recipes for creating any periodic oscillation. Our first task in today's lab will be using an applet to create complex oscillations from a series of harmonics. By adjusting the height of the first row of dots, you can select the amplitude of each mode. The second row of dots allows you to change the phase of each mode. By selecting a non-zero amplitude for multiple harmonics, you can add the harmonics together. The superposition of the selected harmonics is shown in red. To look at a single component harmonic, place your mouse over the amplitude button that corresponds to that harmonic. By checking the sound box, you can hear what the oscillation you built sounds like. To save a waveform that you have built, click on the Save Waveform button in the lower right-hand corner of the applet. To display this waveform, check the Show Saved Waveform button. You can also show the superposition of the saved waveform and the current waveform by checking the Show Superposition box. The current waveform is shown in red, the saved waveform is shown in blue, and their superposition is shown in green. To look at different wave shapes and their component harmonics, choose from the Functions menu to select the wave shape. Now that we have made different wave shapes from the component harmonics, we will use a different program to break down a complex oscillation into its components. The top graph shows the amplitude of the signal versus time, and the bottom graph shows the frequency of the different harmonics versus the amplitude of each harmonic. If I sing into the microphone, ah, and click inside the window while I am singing, I can obtain a Fourier spectrum of my voice. I can then move my mouse over the different peaks to obtain their frequencies. Each of the different peaks is roughly an integer multiple of the fundamental frequency of 235 Hz. We can play anything into the microphone and have it Fourier analyzed, like this version of Chopin's Nocturne. What can you think of to Fourier transform?